We are Group 17. This is a presentation for our first lab. My name is Justin DeCoke.
My name is Sachin Patel.
And my name is Ranjith Kumar.
We will go and get right into the presentation. So quick overview. This is kind of in two distinct sections, the database design and then the database implementation. So we'll go ahead and get into the design. So we ended up going with the three schema architecture. We've got the registrar schema and the facility schema and the housing schema, which all of the tables in the database will be broken out into, and all of the data structures will be normalized in the third normal form. We took the required data elements that were listed in the assignment, made that kind of our preliminary field list, which was touched on in chapter 7 of the Hernandez book, Database Design for Mere Mortals. Generally, you're designing a database, you start with a preliminary field list and then a preliminary subject list. From these data elements, we created some usable field names in the Pascal case that determined which subjects that specific piece of data actually represents. So from here, we kind of had to make a few assumptions and considerations around this data, just to kind of put us in a path. So first assumption we made is that the school is a college. Next is that the classrooms and the dorm rooms cannot exist in the same building. Three is that students would be required to take certain courses based on the major that they are in, and then therefore some courses need to be related to different majors in some way. Next, mini classes start and end on the same dates as other classes. So this would be like we have like fall 1 and fall 2, spring 1, spring 2. So here is the list of tables that we ended up with. So this is kind of developed from the list of subjects. So here are the primary keys, and student ID is the only one that was able to be identified as a primary key just because of its numeric and unique nature. So all of these other unique IDs were created with the creation and design of the database to bring this to third normal form. There are several relationships within the table. Here's a few key relationships in the database. So an academic major can be related to many student IDs, but a single student ID can only be related to a single academic major. Moving on, here's that database diagram. So you can see student ID is a foreign key, and in some cases the primary key, foreign key in several tables. And with the creation of those keys, we had to set some kind of naming conventions to make sure everything relates okay. So these are just basic rules that we'll see kind of come to fruition in the next few slides here as we start implementing the database. So here is kind of more in depth in the schema design. So the registrar owns any tables with like student detail, like their name and that sort of thing, course detail, academic programs, majors, schedules, that sort of thing, and then facilities, would own anything that's like physical property, buildings, classrooms, and then housing is kind of the relation of those two. It's the students that are in the facilities. So now moving into the implementation of the database, this is the start of our DDL statements. So creating the database, the schema, and the facilities tables, order in which all of these statements are laid out is very important in making sure everything creates correctly on that first execute. So these are our registrar and our housing tables. Most everything is a not null score. Can be null, and that is by design as well, which we'll see in the coming few slides with some stored procedures. And here we're going into DML. So these are just some manual inserts of data. One thing to note is that all of these course names, all of their course ID here starts with a 4-character string, and these all relate to a major. So this is going back to that assumption that students have to take certain courses based on their major, or these insert into selects. This one matches those on this substring. And same here, the student transcript, this basically just copies what we just did here with default values for of NA for the grade and then 0. Okay, so here we created this and a couple other stored procedures to help with making an easier way to insert those records. So this one, facility.insert rooms, checks whether the building is a academic building, which it gets here by taking the first character of the building ID, and if that first character is 1, that means it's an academic building, and it'll insert building ID and classroom ID and room number into the classroom table, and then if that number is 2, it puts it into the dorm room table. But first, it inserts a new building into it based on the building ID that you give it, and then the number of rooms that you want to add in, and then goes through a while loop to add as many rooms as you want, incrementing up by 101, 102, 103, etc. So then we created a facility to add buildings, which you give it a number of buildings and the rooms per building and the building type, and then it'll insert all the buildings and all the rooms by doing some while loops and then executing the insert rooms function within those while loops. That is what we ended up doing to insert our data, or we executed this stored procedure twice. one for the academic building and one for dorm buildings to insert all of our building. The downfall with that though is then that this rename new building plus then the building ID is the name of the building instead of a real name. So we created this real quick stored procedure to update the building name to a real name. So this was all of the data entry in terms of like actually typing. So then the last couple stored procedures here goes back to this right here where we entered this NA and this 0. This first one, assign letter grade, very simple in concept. You give it the score 0 to 100, and it essentially puts in a grading scale here and returns the letter grade. Registrar.random score here uses the transact SQL rand function here to create a random integer for each student, and then it passes that as their score. Lastly, getting back to a little bit of DDL with creating our views. So this one is the list of students, and then you've got the classes for 2 of the students. Is the 2 students right here. We've just had to go in and change those student IDs to get different students, and then students that are in 3 of the dorms, and you can't actually see all 3 right here because there's a lot in this dorm, but we'll see it when I run it. The database satisfies all the requirements of third normal form, and there's a couple of opportunities for improvements for sure in different subset tables. One example is like the building type. It could be a building type code. So there's certainly a few opportunities for that in there. And then I was kind of going back and forth with whether to put major ID in the course table or keep it how it is where it's the substring. I ultimately decided to do the substring, but I would want to do some more research to kind of see what would be the better option. Also with the student transcript, I think there's definitely with that and the student schedule, they both have very similar data. So I think there's probably an opportunity for like a surrogate key or something like that in that table that could be helpful. We made sure to design this database with expansion in mind. So that's kind of why there's like the housing schema, which only has one table in it, but in real life, that would be a lot more expansive. And then same with like facility, like a real facility department at a real college would have several tables. And there's also several stored procedures that would need to be written to expand functionality. All right, so I'll bring in SQL Server Management Studio on the VM and run this. And then we'll be able to see our views here. So the student ID and their name and major dorm is, and then their grades on all these classes. And then you can see this term broken out with the start and end date. And here's the building name and then the classroom. And then here we can better see all the students in 3 of the dorms. So that is our database that we created for lab 1.